So the STD-601 is a transceiver for industrial remote control and telemetry. It's a narrowband transceiver with simple serial interface. It has own communication protocol and transparent interface. It complies with EN 300-220. It also has programmable power settings and data rates. So there are two versions available, single or multiband. RF power, data rate certification, current consumption varies. The applications for STD-601 include telemetry or industrial telecontrol, the PC application can generate settings for the Arduino and STD-601 by connecting switches and LEDs to the Arduino ports. We can transmit and receive switch data and analog data. You can set band, RF power, data rates, channel and communication mode. An LCD screen provides easy visualization of values. The STD-601 requires two serial lines. STD-601 RF setting commands TXD and RXD. Input user data using DI and DO. To set up a communication system, we designate TX and RX and set the boards using the PC application. For range tests, the settings can be saved to the board, allowing the test board to operate without connection to a PC. So start application and select USB port. Select language and STD-601 version. Then press the connect button. So the application fetches the current STD-601 parameters and Arduino settings. By clicking on the corresponding tab, the check marks show current settings. Ports 1 to 8 are connected to Arduino A0 to A7. They are capable of logic I/O or operation as analog input. By selecting values and pressing the Go button, we can program the STD-601. The settings have been input successfully, and we do the same on the RX board. The final values are displayed on the LCD. The 0 is the TX and 1 is RX. So there are various communication modes. This is one way. So push the button 1 to 4, the corresponding LED lights on the RX board. So set the TX board first. This board assumes overall control. Select one-way communication mode. For the other board, you choose RX and select the same mode. Now I press the switch and LED comes on. Note the TX and RX LEDs come on. Now I select one-way continuous. To avoid duplicating settings, only new settings are sent. So the switch state is transmitted continuously. For two-way, when I push a button, the switch state is transmitted. The corresponding LED comes on. I push the button on the other board, and LED will flash on the first board. I select two-way and do the same on the RX board. I push the button and LED comes on. Now if I push the button on the RX board at the same time, the LED lights on the TX board as well. The ACK LED also lights to confirm signal from the RX. Now we change to two-way continuous. As before, but now I can operate switches on both boards independently. By setting the ports to function as analog inputs, we can input analog voltages to the ports and transmit their values. You need to select telemetry on both boards. The external ports can process high, low, I/O or analog signals. We need to select port 1 as analog in on both boards. The values are transmitted back to TX, where they appear on the LCD screen as 0 through to 99. We can set the board to act as RSSI monitor for the current channel. On the RX board only, do not need TX, select Get RSSI Level. Now I can remove the antenna and watch the RSSI level change. So for packet error test, transmit 1000 packets from TX to RX. The RX counts successfully received packets. Select Get Packet Error on both boards. So start the packet test. Press the second button to stop. For more details, you can visit our website where you can find out how to get the sample code for the Arduino.